Hey everyone, and welcome. Have you ever wondered what is really going on inside your phone or your laptop? Well, today we're going to peel back the cover and understand the fundamental blueprint of a computer. And we're going to meet the tiny little genius at the heart of it all, the CPU. All right, let's get right into it.
I mean, really think about it for a second. When you click your mouse or tap your screen, you're setting off this incredibly fast chain reaction. But how does the machine actually know what you want it to do? That's the big question we're going to answer today.
You know, the secret to all of this lies in something called computer organization. You can think of it as the master plan, the architectural blueprint that lays out how every single piece of hardware is connected and, crucially, how they all talk to each other to get things done.
Now, to really wrap our heads around this, let's use an analogy. Imagine your computer isn't a box of electronics, but a big, bustling office building. Computer organization is the blueprint for that building, making sure every department is in the right place so they can all work together like a well-oiled machine.
So this high-tech office of ours, it has 5 absolutely essential departments. In the tech world, they're called functional units, and each one has a very, very specific job in the grand flow of information.
Let's do a quick tour, shall we? First, you've got the input unit. That's the mailroom, where all your clicks and keystrokes come in. Then there's the memory unit, which is basically the building's massive file archive storing all that data. The output unit? That's the shipping department, sending the final results to your screen. And right at the core of the operation, we have the control unit, the manager directing all the traffic, and the ALU, the expert who does all the number crunching. These last two are so important, they actually work together in the executive suite.
And that's exactly where we're headed now, straight to the top floor, to that executive suite. In our computer office, this is the home of the CEO, the Central Processing Unit, or as we all know it, the CPU. It is without a doubt the brain of the entire operation.
And look, when I say brain, I'm not just using a buzzword, I mean it. This one single tiny component is the command center for absolutely everything that happens.
And this is really the key. This tiny little electronic chip, which is also called a microprocessor, is the engine that drives it all. It's the place where raw data gets turned into the websites you see, the games you play, and the work you do. Literally, nothing happens without the CPU's say-so.
But, you know, even a brain doesn't work completely alone. Inside the CPU's own office, it has a small, super specialized team that helps it manage and process all this information at unbelievable speeds. So let's meet this team.
First up is the control unit, or the CU. This is the office manager. It's the traffic cop of the CPU. Now, the CU doesn't do any of the actual heavy lifting or the math itself. Instead, its critical job is to fetch instructions from memory, figure out what they mean, and then tell all the other parts of the computer what to do next. It's the ultimate coordinator.
Next to the manager, you have the arithmetic logic unit, or ALU. So if the control unit is the one pointing fingers and giving directions, the ALU is the math genius who rolls up its sleeves and gets the actual work done. It handles every single calculation, all the adding, subtracting, you name it. And it also makes all the logical comparisons, like checking if one number is bigger than another. This is the superpowered calculator of the team.
And finally, we have registers. The best way to think of these is like the CEO's personal sticky notes. They are tiny but unbelievably fast, little storage spots located right inside the CPU itself. They hold the exact piece of data that the CPU is working on right this second, which means it doesn't have to waste any precious time going all the way back to the main memory archives to get it.
So, you've got this team in place. The manager, the math expert, and the super fast sticky notes. How does the CPU actually get anything done? Well, it follows a simple, relentless 3-step rhythm for every single thing it does.
The whole process boils down to this constant 3-step dance. First, the control unit fetches an instruction from memory. Second, it decodes that instruction to understand what it needs to do. And third, it executes the command, which usually means handing it off to the ALU for a quick calculation. Fetch, decode, execute, again and again and again. So how fast are we talking here? Well, in a modern computer, this 3-step dance is repeated billions of times every single second. That speed is measured in gigahertz, or GHz. So when you see a computer with a 3 GHz processor, that means this cycle is happening 3 billion times a second. That's what you experience as speed. And you know when your computer feels slow or it starts to lag? It's often because the CPU is just struggling to keep up with this relentless cycle for all the different tasks you're asking it to do. It's
It's truly mind-boggling.
Okay, wow. So we've toured the office building, we've met the executive team inside the CPU, but why does any of this really matter? Why is it important to understand this stuff? Let's zoom back out and put it all together.
So here's the main takeaway. Every incredible, complex thing your computer can do, every video you watch, every photo you edit, every world you explore in a game, is all built on a surprisingly simple foundation. It's just a few core parts, each with a very clear job, working together in that relentless fetch, decode, execute cycle, running at a speed that's almost impossible for us to imagine.
And you know, that foundation is really just the beginning. Today we focused on the brain that processes all the data, but where does all that data actually live? From those lightning-fast sticky note registers to the giant archives on your hard drive, the world of computer memory is a whole other fascinating topic. So what do you think? Should we dive into that next? Let me know. Thanks so much for joining me on this little tour of the computer's inner workings.